The concepts of weight and weightlessness are concepts that are often misunderstood. So let's take a look at weight and then weightlessness. We usually say that weight is the force due to gravity that acts on something. Phil Physiker stands on a weighing scale. The weight he reads is the force exerted by the scale to hold him up, which is the same as the force of gravity pressing him down against the scale. So we see two forces that act on Phil. There's the downward force of gravity, mg, that presses him against the scale. And there's the upward normal force, N, the support force provided by the scale. What the scale reads is the magnitude of the pair of forces that are squeezing the scale, Phil's downward push and the floor's upward push. Both squeeze a spring-like device inside the scale that is calibrated to show weight. Suppose Phil jounces up and down on the scale. Then he sees fluctuations in his weight reading. But the force due to gravity on Phil is constant. What Phil sees are fluctuations in the normal force N. What's this tell us? It tells us that when weighing ourselves, the reading is the normal force acting on us. And the normal force is a support force. So Phil's weight is the force he exerts on the supporting surface, the scale. When in equilibrium, no jouncing, the support force N is equal in magnitude to mg. Suppose the floor gave way and fell beneath Phil and the scale. Phil would no longer press against the scale. Likewise, there would be no support force and N would be 0. The scale would read 0. But the force of gravity, mg, still acts on Phil, as evident by his unfortunate downward acceleration. So again, your weight equals the force with which you press against a supporting surface. Which brings us to the concept of weightlessness. If no support force acts on you, you have no weight. You are weightless. Here we see a cliff with the ocean below. Daredevil Dan is in a car about to drive off the cliff. Before driving off, Dan sits on a weighing scale that reads his weight. As long as the car is supported, mg is matched by a support force N. But when sailing through the air, N is 0. But mg is still there. Daredevil Dan is weightless, but not for long. Upon landing, N is huge. Ouch. Astronauts in orbit are in a sustained state of weightlessness. They are without a support force. But mg toward the Earth, perhaps with a smaller g, is still there. Future space travelers, however, need not be subjected to sustained weightlessness. As mentioned in previous screencasts, lazily rotating giant wheels or pods at the end of a tether will likely take the place of today's non-rotating space habitats. Rotation effectively supplies a support force and nicely provides weight. I want to leave you with a question. If you were in a freely falling elevator and you dropped a pencil, it would hover in front of you. Is there a force of gravity acting on the pencil? Defend your answer. Until next time, good energy.